Hi everyone, in today's lesson we're going to talk about how to find limits algebraically at vertical asymptotes. So as we've always been doing, we're going to always try direct substitution first. If my answer is a real number, then we know that that's our answer. If we get a whole 0 over 0, we know our ways out of that. But this today, you're going to get if your answer is a number over 0. If your answer is a number over 0, that means that there is a vertical asymptote in the graph. And with a vertical asymptote, there are really only 3 visual representations that you can get. So just look at these examples. So example number 1, both the left and the right side of the graph at x equals -4, they're both going down to negative infinity. So since the left and the right are going to the same place, we can say this limit is negative infinity. Now, same thing in second example here. We have the limit as x approaches 3. So the limit from the right and the limit from the left are both approaching the same y value of positive infinity. So when you have these two scenarios, it's clear as day what the answers are. Now, how do we do this algebraically? So let's do these examples. So again, we're always going to try direct substitution first. So everywhere I see an x, I'm going to put in a -4. So -4 plus 3, and then -4 squared plus 8 times -4 plus 16. So take a couple seconds, and in the calculator, do this separately. Do the top separate from the bottom and get 2 different answers. Once you get that, you can hit resume. All right, so the top, I got -1. And the bottom, I got 0. So look, we've got a number over 0. This means we have a vertical asymptote in the graph. So if you didn't have the picture and you just had the equation, you would have to try your direct substitution. You get your number over 0, so you know it's a vertical asymptote. So in order to decide if they're going in the same direction or not, we have to do a little bit of testing. So this is where we're going to do step 2. So step 2 is we need to check the left and the right side of the graph. So we're checking the left and the right side of x equals -4, right? Not of the graph particularly, but of this specific value. So we want to know at maybe, if I could make a small point here, maybe at -4.1, or maybe to the right of it, -3.9, right? As close to -4 as you can get. I want to test those values. So I'm going to test the left side. So left of -4 is this way, right of -4 is this way. So left, we're going to test x equals -4.1. And then the right side of the graph, or the right side of 4, is over here. We're going to test -3.9. And the goal is to see where the graph is headed. So I'm going to go ahead and do the substitutions. So we're going to substitute directly the way that we did in the original problem. So we're going to put -4.1 on the top, plus 3, divided by -4.1 squared, plus 8 times -4.1 plus 16. Now, you could put this in the calculator just the way you see it and get a number. So why doesn't everyone do that? Use alpha y equals and put it in as a fraction, and then hit resume when you're ready for the answer. Okay, so what I got was -110. So what that means is when x is at -4.1, this graph, the y value, is at -110. So that will show you that the graph is actually going to go down to negative infinity. This number doesn't have to be extremely large, it just has to be negative, because we already know that there is a vertical asymptote there. So we know it's going to go down forever. So this negative number there tells me that the left side of the graph is going to go down to negative infinity. So now we're going to do the same thing for the right side of the graph. So the right side is -3.9 here, and we're going to plug in just the way we did. So -3.9 plus 3 over negative 3.9 squared plus 8 times 3.9, negative 3.9, plus 16. So take a minute, pause the video, and try that and get an answer and hit resume when you're ready. Okay, so I got negative 90. So again, the negative 90 just tells us the y value. When x is negative 3.9, the y value is negative 90. So it's obviously going down to negative infinity. So since the left side is going down to negative infinity and the right side is going down to negative infinity, we know that a limit exists if the left and the right side are equal. So since they're equal, we know that step 3, I kind of ran out of room here, I'm going to put it here. Step 3, the answer is that the graph is going to negative infinity because the left side equals the right side. So if you wanted to try example number 2 on your own, you absolutely could. This is the same scenario where the left and the right side are going to be approaching now positive infinity. So why don't you pause the video and just try this and see what happens. And then hit resume when you're ready for the answer. All right, this is what I got. Okay, so I did direct substitution and I got a number over 0. I got 4 over 0. So now I've decided that I need to check the right and left side of this x equals 3. So if it helps, you could draw a little number line over here, right? Here's where x equals 3 is. Here's the left of 3, here's the right of 3, and you want to get as close to 3 as possible. So if 0 we know is over here, this as close to 3 as you can get is probably 2.9-ish, and then as close to 3 you can get from the other side is 3.1. So that's how I got my left number and my right number. So I plugged 2.9 in for x, I got 390. I plugged 3.1 in for x, and I got 410. So since these numbers are positive, we know that the graph, since it's a vertical asymptote, is going to go to positive infinity on both sides. So since the limit from the left is equal to the limit from the right, we know that this limit must be infinity. It's going, both sides are going to infinity. All right, what happens if the limit from the left does not equal the limit from the right? So that leads me to example number 3. So we have the limit as x approaches negative 1. So look at the example graphically. Here's negative 1. So if this right here is your negative 1, your vertical asymptote, the limit from the right is going up to infinity. The limit from the left is going down to negative infinity. So since the limit from the left does not equal the limit from the right, this answer we know does not exist. So we need to prove that algebraically. So why don't you guys take a minute, plug a number in that's left of negative 1, that's a right of negative 1, and see if you get that it's going in 2 different directions. So take a minute, pause the video, try it, and then hit resume when you're ready for the answer. All right, this is what I got. So just to review, I tried direct substitution first. I got a number over 0. That proves that I have a vertical asymptote in the graph. So I needed to check a number that was left and right of the limit value at negative 1. So if you're having difficulty figuring out what numbers to choose, you always want to make a number line, right? Put 0 on it so you know where it is. Here's negative 1. So we know to the left of negative 1 and to the right of negative 1. So to the right of negative 1 is probably negative 0.9. And to the left is negative 1.1. So just be careful making those distinctions. If you draw the number line, I think it might help. So I plugged in negative 1.1, which is the left side, and I got negative infinity. So look, that proves this. Then I proved the right side, I plugged in negative 0.9, and I got positive infinity, which goes up here. So since the left and the right are not equal, the answer does not exist. Just for purposes of time, I'm not going to do these examples, but I actually would suggest you guys try them now, and maybe we'll start class off tomorrow that way. All right, have a great night, everyone.